Okay, here are some examples of hash functions. So these are the actual algorithms that you would use if you wanted to implement a hash function. And these are algorithms that attempted to provide one-wayness and collision resistance. Some of them succeeded, some of them failed. So a very old hash function that attempted to be secure was called MD5, but this is from, I think, the 1990s. And at this point, people have found all sorts of attacks on MD5. So if I give you an MD5 output, you can break one-wayness. You can find an input that hashes to the same output. If I asked you to find an MD5 collision, you could do so. You could find two different outputs that map to the same input. So although it was initially designed to be secure, as of 2025, this thing is completely broken, and if you use it, it's not for cryptography. People still use it as a hash function for other purposes, like the fingerprint on the document or something, but if your goal is to get integrity or one-wayness or collision resistance, MD5 is not going to help you. It should not be considered secure anymore because it's too old. And in fact, here's an example where someone broke the MD5 hash. They found a picture that hashes to this value. So it's very bad. So MD5 was the first attempt, and it didn't work at all. So sometime later, something called SHA-1 was designed. And this was secure for some time, but attacks were found. And as of 2017, you can't use SHA-1 anymore either for security. If you do, it's not going to be good for you. People can find collisions on SHA-1. They can reverse SHA-1 hashes, give it an output, find an input that matches the output. So SHA-1 is also broken, although older systems might try to use it. You can't use it anymore. It's no good. So then they moved on to SHA-2, and something I haven't called out yet is that the output size seems to be growing. So notice that now they're starting to provide outputs of 512 bits, and hopefully that makes finding collisions harder. As of 2025, SHA-2, we don't think it's broken, but who knows, maybe in future years it will be. Although some variants are vulnerable to something called the length extension attack, which you will see in your homework, or you can look it up online if you're curious. So there is an attack on SHA-2 that doesn't break one-wayness or collision resistance, but there is something called the length extension attack that it is vulnerable to, that is separate from those security properties that we talked about. So SHA-2 is an option in that it's not broken, but there are some subtle attacks that you can still play on it. And for a lot of people, this is what they use nowadays if they want a secure hash. Even better than SHA-2, though, is something called SHA-3. This is like the newer standard, and it's a little bit different from SHA-2, the way that it works. If you really open it up and look at the code inside, it's a little bit different. But SHA-3 also, as far as we know, is not broken. But I guess if you come back to this video in like 25 years, maybe it will be. But for now, just know that some hashes that are older are broken because of research over the years, and other ones are currently known to be secure, but maybe in the future people will find flaws in them. So those are some examples of hash functions you might see in the wild.